Topic 8, flashcards, right triangles, and trigonometry. We're going to start with just the basics. You have to know what a right triangle is, and a right triangle is a triangle that has a right angle, which means there's one angle that is a 90. The other two angles together are complementary, which means these two, angle A and B, add up to 90 as well. So you have the 90 of those two acute angles, then you have this 90. That's where they make the 180. And the opposite side of the right angle is always called the hypotenuse. The Pythagorean theorem is something you should have learned years ago, but people often forget to remind themselves that it has to be a right triangle. So if a triangle is a right triangle, that's a huge if, then you can use the Pythagorean theorem, where a squared plus b squared will equal c squared. When you do the Pythagorean theorem, there are some patterns that show up on like common right triangles. Those are called Pythagorean triples, where you actually have side lengths like a 3, 4, 5 triangle. This is the most common Pythagorean triple. Basically, it just means that all three sides are whole numbers. There's no decimals, there's no fractions, there's no radicals or square roots. They are all whole numbers. Any scale factor of a 3, 4, 5 triangle would work as well. And here's a list of other Pythagorean triples that are common. But the 3, 4, 5, those are like the most common Pythagorean triples that you will see. Each of those A, B, and C are whole numbers. Geometric mean. This is something that you may or may not use to solve the problems, but some teachers will use this. The geometric mean is literally when you have this right triangle with an altitude. It is the square root of each of these pieces of the side where the altitude hits. So to find this altitude, that height, you take x times y and the square root of that, and that's how you find the geometric mean. So some triangles are special right triangles, and one of those is a 45, 45, 90 triangle, meaning there's a 45 degree, a 45 degree, and a 90 degree. So if that ever happens, if those degrees are part of the triangle, then this is what's true about the side lengths. So first of all, 45, 45, 90, that has to do with the degrees or the angles. But to use that, you actually are talking about the side lengths. So that's kind of confusing. What it says is if you have a 45, 45, 90 triangle, each of the legs, those are the sides that touch the 90, will be exactly the same. They're going to be congruent. The side across from the 90, the hypotenuse, will always be, see that x, that side length, whatever the side length is, times square root of 2. Another special right triangle is a 30, 60, 90 triangle. Again, they're talking about the angles 30, 60, 90, so you can identify the triangle, but what it helps you find are the side lengths. So first you need to identify the shortest side. The shortest side is always across from the 30. The long side is always across from the 90. And then the hypotenuse, the 60, and the hypotenuse is always across from the 90. So once you have the short side, to find the long, you just take whatever the short side is times square root of 3. So in this case, the short is A, so the long would be A times square root of 3. The hypotenuse is always 2 times the short side. So again, the short is A times 2. So the hypotenuse is 2 times that short side. Trigonometry ratios, otherwise known as trig. There are several different ways to help you remember this, but here they are all in one. The sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Many teachers teach this as SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So now we're going to talk about each one of these. The sine ratio is opposite over hypotenuse. You might see them written in different ways, though. Cosine ratio is adjacent over hypotenuse, written in different ways, just so you recognize them. And the tangent ratio is opposite over adjacent. Now, keep in mind, all these ratios have to do with whatever angle you're talking about. So if I'm talking about this angle, across from it is the opposite. But if I was talking about this top angle, down here would be the opposite. So identify the angle first. Find the angle, then choose which trig function you will be using. If you are trying to find angle measures or the degrees of certain angles, then you use the inverse function right here. See that little -1? So you take the sine inverse, and that's on a calculator or a trig table, Sometimes on a calculator, you would have to hit the second button or a shift button to find that -1 symbol. But at sine, then you take the actual ratio. Take whatever the opposite over the hypotenuse is. So take opposite divided by hypotenuse. And once you plug in that sine inverse, that's how you get the angle. Same thing, cosine inverse, divide adjacent over hypotenuse, and you will get the angle. Tangent inverse, opposite over adjacent, and you would get that angle. Angles of elevation. We're actually going to talk about angles of elevation and depression. So if I look straight out and I am horizontal to the ground level, so if I'm looking upward, then I'm taking my line of sight and looking upward. That's an angle of elevation. It's going up from the horizontal. Okay, so whenever you're looking upward, that's the angle of elevation. But if you're looking for the angle of depression, you take that horizontal viewpoint and go downward. That is the angle of depression. So these two rules that I'm going to go over now, they might not be used for all classes. So at our school, in Rio Rancho Public Schools, these law of sines and laws of cosines that we're going to talk about, these are just done in the AP classes, or the pre-AP classes. So advanced classes only, you would have to know this. So if you're in regular geometry, you are good. But laws of sines, these can be used in any triangle, which is amazing. It doesn't have to be a right triangle. So you would find that the proportions or the ratios of the sine of one angle, so if I took the sine of this angle, like and actually plugged it in, sine and plugged in the angle, then divided by A, that's the side opposite, that is going to be congruent to or equal to sine B over B and sine C over C. And this can help us solve, when we use these, you might not use all three of those fractions or those ratios. You might just use two of them and set up a proportion and set them equal to each other. But this is the law of sines, and it helps you find missing side lengths and missing angles, for that matter, of triangles that are not necessarily a right triangle. Law of cosine, same thing, advanced classes only. The way they write these rules, you do not have to remember all of these rules. Just focus on one of them. If I was trying to find one side length, like let's say this one right here, side A, I would take the two other sides and square each of them. So other side, that's B squared. The other side, C squared. And then I would subtract 2 times each of those other two sides, B and C, times the cosine of the angle across from the side I'm looking for. So all these rules are the same. If you're looking for a side squared, you take the other two sides squared, subtract 2 times the other two sides minus the cosine of the angle across from the side you're looking for. And when you do these example problems, it makes it a little bit easier. But right here, those are the rules. I've left you a couple blank flashcards. If you need to add any more, feel free. I hope that helps.